Welcome to this 10-minute expert insight video podcast produced by INEA. I'm Charlie Ashton with 21K Consulting. And in this series of podcasts, we're talking to industry experts about trends and challenges in IoT, SD-WAN, edge compute, and network virtualization. Today, I'm delighted to welcome Jeff Wittich, Senior VP of Products at Ampere Computing. So before we start talking about the main topics for this podcast, Jeff, can you tell us a little bit about yourself and about Ampere Computing?
Sure. Thanks, Charlie. Glad to be on with you. Like you mentioned, I'm the head of products at Ampere Computing. We're about a 2.5-year-old company with global engineering, marketing, sales teams, and we're focused on developing and delivering the next generation of CPUs for the cloud, all the way from hyperscale out to the edge. And that means industry-leading performance, scalability, power efficiency, all 100% focused on what the cloud needs.
Great. So when you recently announced the Ultra processor, you tagged it as, quote, the world's first cloud-native processor, which is a great tagline. But why do cloud-native workloads need a new processor platform? What's that all about?
So back in March, we announced Ampere Ultra, and you're right, we called it the world's first cloud-native processor. And as you know, over the last 10 or 15 years, we've seen a major shift to the cloud. And with that big shift to the cloud, we've also seen a large shift in the software model. Mm-hmm. We've moved from monolithic apps running in isolated enterprise data centers to now really a much more agile approach with applications broken down into microservices and then running in containers or as functions, all in the cloud.
Yep.
And so this shift to cloud native means that really the underlying compute model has changed as well, and the needs have changed. So the objective now is to increase your services density, all with consistent and predictable latency, while not sacrificing the security of your end users. And so what that means is you want more cores with predictable and high performance. You want to have scalability across the whole platform, whether that's the compute, whether it's network, whether it's memory. And you want to do all that with leading power efficiency and density. And so that's what we really did with Ampere Ultra is we built it from the ground up to uniquely meet all of those requirements. And we did so without being encumbered by all the legacy requirements that just don't matter in this space at all. And there's no other processor out there that was architected from the ground up for the cloud. And for example, Xeon launched 22 years ago. And when Xeon launched, the closest thing we had to the cloud at that point was AOL. It was people's web pages on GeoCities.
Yeah.
So 1998 was a long, long time ago. And the world is overdue for a new processor.
Right. Yeah, no, thanks for explaining all that background. So obviously there are a number of other processors available for edge applications that are also based on the ARM architecture. So what makes Ultra a superior solution in this market space?
I think it really comes down to the fact that it hits a real sweet spot in terms of performance and power efficiency. Because the edge requires platforms that can run in distributed locations. Sometimes those are really truly remote locations where you don't have a lot of the same capabilities around power, around cooling. And so having the ability to really scale out to a low TDP envelope is really, really important. So the same Ampere Ultra processor that can run at top end performance all out in big hyperscale data centers, it can also scale out to low power at the edge. So while there's other ARM processors that can hit 45 watts and are perfectly acceptable for the edge, they just don't have the level of performance that a lot of the fast-growing and emerging edge applications really demand. They don't have the core count, they don't have the performance within the core that Ultra has. And because things like 5G, as well as other emerging edge use cases really require you to run and are enabling you to run additional services on top of that infrastructure that you've built out, it is important that you have a lot of performance. So Ampere Ultra really uniquely hits the power requirements you have from an infrastructure and environment perspective, but delivers up much greater core count, much greater performance, so you can scale out to whatever application the future demands.
Yeah, that makes sense. Thanks. So also a couple of years ago, I guess you introduced the Ampere EMAG processor. So what market needs does that one address, and what advantages does that provide compared to the other solutions that are out there?
Yeah, Ampere EMAG was a really successful product for us in really kickstarting the development work on Ampere, and then also hitting a couple of critical markets. So Ultra delivers much higher levels of performance than what EMAG did. But EMAG was an incredibly efficient processor, and one that was delivering a lot of those same consistent performance, consistent latency requirements that the market needs. So we specifically found a couple places where the market really embraced EMAG. One is with ARM native applications. There was a big desire to be able to run ARM native applications on ARM servers rather than running them on x86 or running them on ARM devices that just are not servers. And so we've found a lot of success there. One of the use cases within that is Android in the cloud. So it's running Android applications, but not running them on your phone. It's streaming them to your phone and running the application out at the edge or in the cloud somewhere. Right. And that could be desirable because of security. It could be that you don't want someone to have to wait what could be minutes, hours to download a really large application. It also just could be, someone has a lightweight client device. Yeah. So that's been one place that EMAG really excelled. The other place that it does a really good job at is any kind of containerized environment. Okay. And so architecturally, what we've done at Ampere is very well suited for containers, for functions. And so EMAG really gave us a good start there with getting a very dense and scalable solution where you can add many additional containers and the processor doesn't fall over any. You don't kind of fall off a cliff and find yourself unable to scale. And that's because we've packed in so much performance, so much I/O, so much memory bandwidth, for instance.
Right. So what kind of software environment is available to enable developers to leverage these architecture advantages that you've been talking about?
Well, the software ecosystem, when it pertains to ARM, has really come a long way in the last 5 years. So if you look at the overall stack, all the major OSs are all enabled for ARM and for Ampere. All the Linux distributions, Windows runs, FreeBSD. And then when you go up the stack, all the major hypervisors are supported, as well as key containerized technologies. So Kubernetes, Docker, those all run. And then also, when you look specifically at the edge and some of the applications there, a lot of the key VNFs, there's dozens of VNFs now that have been enabled to run your network functions. So the ecosystem is becoming very mature, and Ampere's been doing a lot of work in that space with key partners.
Okay. So can you talk about some of those, I guess, end-to-end solutions for edge use cases that you've enabled in collaboration with your partners?
Yeah, exactly. One of the key partnerships has been with ENIA, and so we've partnered up with ENIA to create a really interesting opportunity around a UCPE platform. So a platform specifically for telco edge applications where people can run their VNFs and get the advantages of Ampere. So we started with the EMAG processor. We worked with ENIA on NFV access. So that's a really scalable UCPE virtualization platform. And then we also worked on key VNFs like SD-WAN, for instance. So getting all those enabled. And then none of this works unless you have the right hardware underneath it as well. So we also worked with WeWin to create an open edge platform, really a white box style platform that would be very attractive for telcos and for the edge to adopt.
Okay. Yeah. So what about customers? Can you talk about some customers that have adopted your platforms?
Sure. Yeah. So we've had a number of customers that have adopted our platforms and that are going to be adopting the Ampere Ultra platform. A couple I can talk about are Packet is one. Packet's very active in the edge space. They're working with a lot of large telcos on their edge deployments, on their 5G deployments. So Packet is using our eMAG servers in a bare metal environment and across a number of use cases. So the edge use cases that I mentioned. Also, two other really good examples of people in Packet that are running eMAG are Travis CI. They do CI/CD environment, and then also Hatch. And Hatch is a mobile gaming company.
I'm familiar with that.
So a couple of really interesting examples there. And then as we look forward, we've also been partnering with some other major players in the industry. Oracle, for instance, announced back in March as well that they're partnering with us on Ampere Ultra. And there's a number of others out there that haven't quite gone public yet, but I think you'll start to hear some exciting announcements from a number of big telco providers, both in the US and some big players out in China as well. So lots and lots of adoption, really exciting.
Okay. Well, that's great. Well, thanks, Jeff, for these fascinating observations. So for more information on Ampere, please do take a look at their website. There's tons of information there. Thanks, everybody, for watching this podcast. And please look out for more of these 10-minute expert insights brought to you by Enea. Thank you.